Okay, so last week we discussed until to this particular point. As you can remember, we discussed about the different kinds of file types, right? And with the file properties or the file attributes, right? So today we are going to talk about the directory and file organizations, right? Now, this is not something very new to you, but you are not very much interacting with these kind of things, right? So knowingly, right? You have interact with this kind of file structures and directories uh, unknowingly, or like without sensing it or without thinking about it, right? So basically here they are talking about the folders and the way that they have given you the ability to create the folder structure. So like folder structure means like, you have the ability of creating the folders, and you have the ability of creating folders inside the folders, which we call the subfolders, right? So that is what you call the file organization, right? So without the operating system, you have no ability of creating the folders, right? So the creating the folders, or like given these kind of folder structures, is given to you by the operating system, right? So operating system uh, is providing the ways that where we can categorize our files into different directories and to manage them easily. Otherwise, if you don't have the folder structure, just think about how you are going to store your files, because files will be generated from different kinds of programs. If you use word processing software, it will give you a document kind of file. If you use a spreadsheet kind of software, it will give you an Excel file or a spreadsheet, right? So those are different kinds of files, right? So if we don't have the folder structure, we have to keep all the things in a one particular place, which will create a big mess, right? It is like you are having just one bag without any pockets, right? So you are going to put all toffees and sweets and vegetables and all these things in that particular bag, right? So later, like after a while, once after you collect the things into that, then you will be in a very big trouble. You can't choose the toffees that you want. You can't choose the vegetables that you want. Like you can't choose anything, because you can see it's going to be, right? So the folder structure or the operating system is allowing us the pockets in the bag, right? So in the same way, it is allowing us to create the folders, and we can arrange the files into these folders. So we can keep our music files in a one particular one, and we can keep the movie files in another one, and documents in another one, right? Program files in another one, right? So likewise, and we are given the ability to create in subfolders as well, right? So if you have music files, so like from those songs, you can categorize those things like into Sinhala, into Hindi, into English, and all these things, right? So it is the basic idea about the file structure. And apart from that, file structure is giving you many other facilities, right? Where you have used, but you don't know that you have used those things, right? So directory is the similar word to the folder, right? So which allow you to organize the files. And inside a folder or inside the directories, the operating system will see the files. I told you operating system anyway going to see the files as the ones and zeros in the physical manner. And again, when it comes to the files, it will see those things as directly executable files and the pure text files, right? Deval dekakin eyaata dakinna puluwan, right? So text files means like text-based files, right? Which has text on the file. So basically, in most of the things, we can see them as a text, right? And there is another very specific file called the object files, which are very processor friendly, right? So they are we consider them, these files are already translated into the machine language. That means translated into the language that can be understood by the CPU. So it can directly execute inside the CPU without doing any translation. Later you will learn, when we are learning the programming, there are some specific files which need to be translated first into the ones and zeros using a translator like interpreter or compiler, right? We are going to talk about those terms in the programming language, with the programming languages, right? So using that, then that translator is able to convert those into the ones and zeros, then the computer is going to understand those, right? So those are not called, those are not the object files. Those are considered as the text files, which are created based on the text, right? So like two categories that the operating system sees, like the text files and the object files, right? So when it comes to these file systems, right, as I told you, the systems that is given by the operating system, the first file system that was introduced was called file allocation table system, right, or FAT file system, right? So file allocation table, now we are going to talk about the file allocation table, the structure of it, the way that it works, like in the next topics as well, right? So I'll give you a brief idea about the file allocation table. Now, the FAT file system, or the file allocation table file system, it contains a table which cannot be seen by us, right? But maintained by the operating system, which always tracks the other programs or other file locations, right? So in the hard disk, there are programs which is written here and there on the platters. So using the file allocation table, operating system will be able to access these files in a quicker manner, right? It is kind of a table of content of a book, right? So when you are having a big book with a very big content, we have table of contents which summarize the places, the chapters, the sub-chapters, and the pages of those. So where we can access the specific topic directly, right? So the same way, the file allocation table is maintaining the records in the hard disk on which platter that this particular program is going to be. So if the user is asked to apply, or the user is asked to access the particular place or the particular program, if your computer has the FAT file system, so operating system first look at the FAT, the file allocation table, then find the location, and then access that location directly from the hard disk that is fixed onto your computer, right? So that is how the FAT works. And as per security purpose, FAT file system is always maintaining a copy of this file allocation table in case something wrong goes with the original file allocation table. So it always creates a copy and update the copy according to the FAT updation, right? So when the file allocation table is updated, the copy is also being updated. So it has a backup, right? But when it comes to the FAT file system, it is not a very capable file system. It's just a very primary file system. It did not support for a very larger hard disks, like the hard disk that we are using today. And if a 1 terabyte hard disk is fixed with a FAT file system will not be able to recognize all the sectors on that hard disk, because it is bigger, or like it is beyond its capabilities, right? And there was a character limit when they are going to give a name to a particular file, right? So there are some limitations, right? So because of this, when the Microsoft creates the Windows NT, the version which is called Windows New Technology, right? They have introduced a new file system. Actually, it's an improvement of an FAT file system, which is called the NTFS, New Technology File System, right? So nowadays, you will be able to see NTFS files, or like the file system which is allocated as an NTFS in your operating system. Right now, if I take any of these files now, as an example, I'm going to have the properties of this PDF document. Right. And hold on. If it is not there. Yeah, let me take the things from the hard disk. Yeah. Now, I have taken the property of the D drive of mine, right? So this is my D drive, which is this partition, right? As you can see, the type is local disk. It says file system is NTFS, New Technology File System, right? So my D volume, the partition which is called D, is given with the file system which is called NTFS. So once you have the NTFS file system, all the files that you are creating in this drive or the partition is going to be NTFS type files, right? So likewise, the NTFS was introduced, and with the NTFS, it is added with very nice capabilities with it. So now FAT is improved as NTFS, and it has the ability of encryption, the automatic file recovery option, and the larger hard disk support, and as well as the Unicode encoding support and the access privileges. We are going to talk about the access privileges in the security section. So those are given to this operating system, right? So now it is kind of advanced with it now. Earlier, it was not there. So like if you ask to compare the NTFS and the FAT file system, it's better you remember these factors. So these factors were not there in the FAT file system. So you can say encryption is available in the NTFS and no encryption is available at the FAT file system. Likewise, you can compare very easily, right? So stick to the NTFS and get to know about the NTFS. So the opposite of those, or like the primary part of the NTFS is there with the FAT file system. Right, so that is the story behind the FAT and the NTFS, people. Is that clear? Yes, everyone? Is it clear? Right, great. Okay, so the next part is about the file security, right? Now, when it comes to the file security, operating system allows us the username and the password. Those are the primary security facilities that is provided by the operating system. And some of the operating systems are allowing you to have the security for the specific folders and all these things, but not not in the Windows operating system, right? But still, in the login purpose, you can remember there are many kinds of security facilities are available now. Like if you need a higher security, you can have two-factor authentication as well, right? Like if you enable two-factor authentication, it is not only the password that requires, uh, it needs a second type of permission, right? So like it is like authoring the access in two different methods. So both the methods should be success for you to go inside the system, right? As well as you can consider this access privileges as a security purpose. Now, access privileges means what? So like you can, I think you have experience like in your school labs, in most of your school labs are not allowing you to access the C drive, right? Or sometimes there will be folders which is not allowing you to access. So it is because these access privileges, right? So the system administrator or the operating system administrator, the higher position one, so like in this case, in the personal computer case, us, we can create the access privileges for the people who are under us, right? Or like people who are like having the permission from us, right? So in a school, we usually do like only the teacher logins will be able to access the C drive, but the student logins we have prevent the C drive access, right? So those kind of things can be done by the access privileges. So how the access privileges work? So if I take the properties again over here, it doesn't matter whether it is a partition or whether it is a particular file. We make a ICT කියන එකට. I'll take this EB exams. So I'm sorry. If I go to the properties of this, right, it's going to give me this little window. And using the security, see, I can manage the access privileges. So for authenticated users, full control is given. For system, again, full control is given. The administrator and the users. Now, administrator, that's me, I can have full control. And for users, they only have read and execute, list folder content, and read. That's all. Right? So likewise, we can manage the same folder or the same component given the access for two different parties in a different way, right? So like as an example, like the teacher and the student. So the teacher is allowing that particular file to access, and student is not allowed to access the same particular file, right? So that is what you call access privileges, right? So it is again one of the security methods. So it will give the security up to a certain period, or like for a certain people, certain parties, right? So yeah, so that is the overview, right? With the aspects of the operating system. So next we are going to talk about the file storage management. Now this is something for you to understand very clearly, because now in 2020 paper, they have given a small question regarding this, right? So we have to discuss that as well at the end of the lesson. So it's better you remember, better you get to know how these allocation methods are working, right? Okay, so let me illustrate it to you. Now, when it comes to the operating system, there are three types of allocation methods or the storage allocation methods that they are using. Now, storage allocation is what? How the operating system is allowed a file to store inside an storage. It doesn't matter whether it is a hard disk or a CD or a DVD or a pen drive, it doesn't matter, right? Operating system will always manage that thing, or like manage the storing part with these particular things, right? So the first allocation method that we are going to talk about is the contiguous allocation. And there are three types: contiguous allocation, next one is the linked allocation, and the index allocation, right? So those are called the way that operating system can store the data inside a disk. So first we talk about the contiguous allocation, right? The contiguous allocation. So in contiguous allocation, as you can see, now I'll take it from here. So I have given you the hard disk or some storage, let's say, with its file allocation table. Right now, if you look closely, right, you can see now this file allocation table contains three things. One thing is the first name, second thing is the start block, and the third one is the length, right? So the file name, start block, and the length. So the file A, it is starting from second block. Now, what is this block defines? Block means something that we use as a unit of storage. So then we will be able to fill that block from the devices, right? Or like from the data transferring part, right? So we can't say that this particular storage is going to contain this particular size of block. So when we are doing the calculation, it is only it's an assumption that's regarding the capacity, but basically it is the structure of it, right? So now, if you consider the file allocation table, it says the file A starts from 2. So you can see it starts from 2, right? And the length, it says 3. So that means length is given from the blocks, right? So if the length is 3, so the second one, third one, and fourth one are being allocated. Now, why it choose second, third, and fourth? Now, like it is clear why they use second one, because they are asking to start from the second one. But why they use third and the fourth blocks? Why couldn't they use the 7th and the 8th, or like 0 and the 1? It is because the way or the method that they used to do the file allocation. Here they have done the contiguous one. So contiguous means the cells adjacent, right? So those in that manner, when you are given a starting block, you have to consume the blocks which is adjacent to you, right? So it is starting from the second and moving to the third and moving to the fourth likewise, right? Now when it comes to a block may be capable of having a file into it as a whole, right? In most of the cases, you may need different kinds of blocks, right? So all you have to focus is how, if you are given a particular file allocation table, do you know how to illustrate it using this kind of diagram? And as well as you have to consider the other way around as well. Once the diagram is given, if they ask about what is going on with this, right? Or like to show the file allocation table regarding this storage, then you will be able to draw this file allocation table. Right? So contingent allocation is very easy. So as the file A, it starts from 2, penetrate over 3 blocks, right? So 2, 3, and 4 is data. And for file B, starting block is 9, the length is 5 blocks. So that means it's ending up with 13. And file C, starting block is 18 and 8 blocks are needed. So starting from 18 and goes until 25th. And the last one, file D, contains 30 as the starting block and spread over 2 blocks. And E is the 26th, the starting block, and it penetrates on 3 blocks. Right, so now this is easy. Now in the operating system point of view, as well as the hard disk point of view, it is easy for them to store things like this, right? But there are significant problems in here, right? So before I go to the problems, it is very like when something is allocated in this manner, in the contiguous manner, it is very easy for the device to read the things, right? So like now, if you think this is as a hard disk, if I want to access file A, so once I access to the block 2, so the third one is just there, fourth one is just there, right? So that particular advantage is there, right? And if you think about the disadvantages, there is a very huge disadvantage which says like there can be situations where you have empty blocks here and there, but still you won't be able to store any file inside it, right? So as an example, if I want to store, let's say it's going to be file F, and I need to store this particular file F in 10 different blocks, or like 10 different containers. Now, if you map this into the file allocation, or like the if you think about the method of the allocation, that is not possible with this hard disk. Why it is not possible? Now, this contains contiguous allocation. Contiguous means they are staying with each other, or like very closer to each other. So if you want to store a particular program which has 10 blocks in it, there are enough free space. So the white boxes were in free spaces. So you got how many? 4 plus 2 is 6, plus 1 is 7, plus 3 is 10, plus 4 is 14. So you got enough blocks for an allocation, or like to match the file size. But the problem is they are not contiguous, right? So in that case, they are going to stuck what to be done, right? And other than that, sometimes when the data is filling up, let's say we are going to fill up these 3 blocks. So we can fill this, we can fill this, and sometimes a particular box, or like a block, is going to fill halfly. Those can happen, right? So in that case, this empty space is going to be a wastage, right? So that is another disadvantage that you can meet. And there is another restriction for a particular file when they are like working with this model. What is the restriction? Now think about this. Think about this file C. If I need to edit file C and add some things into your file, they are going to be a problem because the file C starts from 18, goes until 25th. And by 26th, they are going to start the other one, right? So then there will be a problem because if you are done any changes to file C, so its file size is going to be increased anyway. So since all these blocks are being used and are being consumed, what to be done? They need another block, but it should be an adjacent one. Now, what's happened to the adjacent one? Adjacent one is having a different file which is starting. So there are no empty space, right? Or like an empty box to fill your newly created data.
So එතකොට ඒක extend කරන්න බැරිද අපිට? ඒ කියන්නේ දැන් ඔතන 25න් ඉවරෙච්ච ගමන් ෆයිල් E එක පටන් ගන්න තියෙන්නේ.
ඔව් 25
අපිට දැන් ඕනනම් memory එක extend කරන්න බැරි.
extend කරන්න බැරි වෙනවා. දැන් ඒකනේ නිර්මාණ අපිට වෙන්නේ ගොඩක් වෙලාවට දැන් CD එකක අපි data write කරාම CD එකේ CDs වල DVDs වල data write වෙන්නේ මේ විදිහට contiguous විදිහට. එතකොට අපිට CD එකේ මැද්දේ ඉඩ තියෙන තැන් නැත්නම් CD එකේ අපි හිතමුකෝ CD එක අපි CDs write කරනවා multi session CDs කියලා. ඒ කියන්නේ කීප වතාවක් write කරන්න පුළුවන් වෙන විදිහට CD එකක් write කරන්න පුළුවන්. ඒවා multi session දැම්මම අර කලින් ඉඩ තියලා ආපු තැනකට ෆයිල් එකක් ගිහිල්ලා ඔබන්න බෑ. යම් පොයින්ට් එකක ඉඳලා ඉස්සරහට විතරයි එයාට allocate කරගැනීමේ හැකියාව එන්නේ.
හරි සර්.
right? එතකොට දැන් අපිට ඕක මේ device එකක වුණොත් real time device එක, as an example, if it happens to the computer, if the computer hard disk is going to store the data in this contiguous manner, what will happen? You will be getting an error message or a warning message saying there is no enough space, or like the file cannot be saved, something like that. But you will be able to see there are enough space, right? So if this kind of thing occurs, there is a small solution for this. It is called the defragmentation, right? Now this particular situation is called fragmentation because the empty blocks are fragmented here and there, right? So from defragmentation, what they are doing is they are taking all the empty blocks to one particular place, and all the return blocks is going to some other place or some other site. So then after, we will be able to store the things contiguously. Okay, people, is that clear?
RAM එකට වගේ අහන්න වගේ කියන්නේ features වගේ නේද අහන්නේ?
මොනවාද මේ නිර්මාණ?
ඒක දැන් exam එකට වගේ allocation ප්‍රශ්නයක් ඇහුවොත් ඒ කියන්නේ.
මම දැන් එකක් කරනවා නිර්මාණ. අපි එතකොට බලමු. ඒ කියන්නේ මම අහන්න පුළුවන් විදි දෙක තුනෙන්ම මම එකක් දෙන්නම්. එතකොට බලන්න. Right? Okay. So I'm moving to the next one. So we'll first discuss the allocation methods, then go for the questions, right? And in the linked allocation, the story is different, right? So in the linked allocation, they have taken only one particular file to discuss this topic, right? As you can see, the linked allocation has a starting block. right? Like in the previous way, it has a starting block and it has a length as well, right? So the file allocation table says the file B starts from the block 1, its length is 5. That means 5 blocks are being consumed, right? But when it comes to the linked allocation, the allocating part is different. So as previously, it will start from the starting block, right? Let's say this is the starting block. So it will store the data. And at the end of this data, or like at the end of this block, they allocate this little space to store a pointer. Right now, pointer means after first block, a detail about after first block, where it should move to refer the next part. Right? So in here, file B, when the file B is start to store, so it start with the block 1. So it has some detail or the pointer details to move to the next one. So it moves over 8. Right, likewise. And in the block 8, it will given the detail of the next block. So likewise, all these blocks are connected with each other. Right? So like from the pointer or Nirmana.
කනෙක්ට් කළා තියෙන විදිහට ටිකක් අමුතුයි නේද? ඒ කියන්නේ අර ඉස්සෙල්ලගේ වගේ length එක 5යි කියලා දීලා තිබ්බට කනෙක්ට් කළා තියෙන තැන් ටික වෙනස් නේද?
ඔව් වෙනස්. ඒ දැන් අපිට විභාගයට ඕක දුන්නොත් එක්කෝ අපිට ඒගොල්ලෝ ෆ්‍රීලි දෙන්න ඕනේ. අපි කැමති විදිහකට මේක කනෙක්ට් කරන්න. නැත්නම් ඒගොල්ලෝ ඕඩර් එකක් දෙන්න ඕනේ. මුල ස්ටාර්ටින් බ්ලොක් එක 1 ඊළඟට 8 3 14 28 කියන බ්ලොක්ස් වල පිළිවෙලින් ගබඩා වෙලා තියෙනවා. Right? And when it comes to the practical scenario, this order is determined by the operating system. Right? Operating system එක තමයි හිතලා බලන්නේ නැත්නම් determine කරන්නේ. දැන් 8 වෙනි බ්ලොක් එක පිරලා ඉවර නම් ඊළඟට 3 වෙනි බ්ලොක් එක ගන්නවා කියන එක තීරණය කරන්නේ operating system එක. ඒතර 3 පිරලා ඉවරනයින් පස්සේ ඒකේ හදනවා pointer එකක් හදලා තීරණය කරනවා right. ඊළඟට යන්නේ 14 වෙනි බ්ලොක් එක. Right, so likewise, one block by block, the data can be filled. And here we can eliminate the biggest disadvantage in the contiguous allocation. So we had that problem of fragmentation to store the data, right? Then fragmentation does not matter over here. Then අපි තව file C කියලා කෙනෙක් මේකට store කරනවා නම් what we can do is we can determine a starting point, right? So if it say okay it's 11, so if the length of the file C is 3, so you can choose any of the files, any 3. So operating system have to maintain when you are going to write, it will keep a pointer. So from here to here, from there to here, likewise, right? So it doesn't matter like whether the blocks are being contiguous or not, right? There is a matter like when you are going to expand, right? When you store the details or when you store the data of the file, it takes comparatively big or a larger space than the contiguous allocation, right? Then උදාහරණයක් විදිහට අපි 1 MB ෆයිල් එකක් contiguous allocation වලදී allocate කරන්න යනවට වඩා වැඩි ඉඩක් යනවා index allocation වල. Not the index allocation, what you call the linked allocation wala. What is the reason? Because it has to take some space from the block to store the detail about the next pointer, right? So there are data ma vitarak neveyi block එකේ store වෙන්නේ. It's data plus the details of next point, right? So it will slightly increase the size or the number of blocks that a file is using to store. Is that clear, people? Yes, everyone? Okay, great. Okay, so, and there is another advantage. We had a problem of extending the file in the previous allocation. File extend කරගන්න අපිට ඉඩ නැති වෙන තැන් එන්න පුළුවන්. Now here they don't have limit to extend, right? They can extend whenever you have the time or whenever you have the space, right? So the make අපි හිතමු දැන් මේ මම දම් පාටින් පාට කරලා තියෙන ෆයිල් එක it's going to grow, so it has the capability of growing all over the storage. හැම බ්ලොක් එකක් එක්කම link වෙවි ගිහිල්ලා blocks ඔක්කොම ඉවර කරන්න පුළුවන්. Right? So it is a kind of an advantage. You can grow your file if you have hard disk space more. Right? Okay, so that's the story regarding the linked allocation. And the last one is called the index allocation. Right, so in the index allocation, it is slightly different from the linked allocation. So what they are doing is they are maintaining a block called index block, right? So in this index block, so each and every file is going to have an index block. So each and every file first start from the index block, right? So in the index block, so index block will only have the index, right? Nothing else, right? So this is the index block. This contains the index like this. And data will be stored by starting from these blocks. We don't know what's the order, that is not been mentioned. Right. So likewise, it can store the data using the index allocation method, right? So when you are going to grow your file, let's say now you need to do the changes and the file grows. So next the operating system will choose what's going to be the next, right? So the 28 is the last block. So if it says 26, right, then this index block is going to update as well. So this is going to be 26 as well. Right. Okay, people, did you get this? Okay. Right, okay. All right, so let's do some questions regarding this. I'm going to write the questions, right? You have to take it onto your book and do the drawing. So diagram in part එක තියෙනවා, file allocation table එක manage කරගන්න part එක තියෙනවා, right? So let's take it like this. I'll write the question, people. You can write it with me. Oh, hold on a second. I think I have some saved work over here. If it's so, we can use that. Yeah. Yes, yes. Yeah. People, there you go. This is the first question. So first try the first question. Then I'm going to give you the next.
සර් ප්‍රශ්න ලියා ගන්න ඕනේ නේද?
ප්‍රශ්න ලියා ගන්න නේද? ප්‍රශ්න ලියා ගන්න මොකද ඔයගලන්ගේ ටියුට් එකේ කොහෙවත් නැහැනේ. පොතේ ප්‍රශ්නේ ලියලා ඊට පස්සේ ඩයග්‍රෑම් එක ඇඳලා පෙන්නන්න. Yeah, here in the last point it says, in here, assume the storage has 24 blocks and the block numbering starting from 0. A block row contains 4 blocks. එතකොට ඔයගොල්ලෝගේ the blocks ටික ඇඳෙන්න ඕනේ. එක block එක row එකක blocks 4යි. ඒක 0 1 2 3 කියලා number වෙනවා. ඒ විදිහට blocks 24ක් තියෙනවා ඔය storage එක. Right?
එතකොට මේක එකක් සර වැඩිපුර වෙනවා කියන්නේ පේලි හරියට බැලන්ස් වෙන්න එකක් වැඩිපුර වෙනවා සර් එකක් පැත්තකින් දැම්මම කමක් නැද්ද යට
නෑ
පේලියට
වැඩිපුරෙන් නැහැ. ඔයාට
නැසෙ කියන්නේ
බ්ලොක්ස්
24 බ්ලොක්ස් ගන්නවා නම්
ඔව් එතකොට
සීරෝත්
හතරේ
එක්කද සර් 24 කියන්නේ
ඕ ඒ කියන්නේ
හරි සර්
බ්ලොක් ගාන 24යි. එතකොට බිඳුවේ ඉඳලා නම්බර් කරනකොට නිර්මාණ බිඳුවේ ඉඳලා 23 වෙනකන් තමයි නම්බර් වෙන්නේ. හරි ක්ලියර් නේ?
හරි සර් සර් එක බ්ලොක් එකයි කියලා තිද්දි එකයිද පාට ගන්න කියන්නේ 22 ගත්තොත් 22 විතරද පාට කරන්නේ
ඔව් නිර්මාණ 22 ගත්තොත් එකයින් තියෙන්නේ 22 විතරයි. Right, Nirmana. Yes, Lalindi, send me the answers though. Send me the answers. Oh, right. Okay. Yes, right, okay. Right, okay. Right, right. Hari Nirmana. Right, very good, very good. So people who have done the first one, you can try the second one. This is the question number 2 as well as question number 3 over here. Right, so I'll show you the answer of the first one after a little while. And Nikini, I received yours. Yeah. Yes, yes, that's correct. Okay. Okay. Okay, right. Okay, yes, yes. Yes, Nikini, that's correct. Lalindi. Yeah. Yes. Lalindi, when you are like choosing a pattern, it's better you use different patterns. එහෙමුණාම වඩා reflective වැඩේ. නැත්නම් අර එක ළඟින් ඉවර වෙන ටික අඳුන ගන්න බැරි වෙනවා. So no worries, right? So it's better you go for that, right? Other than that, it's okay, Dua. Sachintani, yeah, yes, that is correct. Yes, though, yes, right, okay. Go for the second one. And how about others? Akila, how about you? And Bashita, okay, the Pahan Midua. People send me the answers. I need to see.
එතකොට මේක බින්දුවෙන් පටන් අර 23ට දාන්නේ නැත්තම්
Oh, me same storage එක නිර්මාණ same storage එක.
අයින්ස වෙනේම අඳින්න ඕනේ නැද්ද අපි?
වෙනේ ඔයාට දැන් මේකම يعني වෙන අර තියෙන එකේම පෙන්වන්න බෑනේ පුතේ. තියෙන එකේ අපි දැන් allocate කරලා ඉවරනේ.
ඒකෙන් සාර පිළියෙල වගේ කියන්නේ 0 to 23 කියන එකම
0 to 23 තමයි. ඔව් 0 to 23 තමයි. same block, same block. අකිල කොතනද ක්ලියර් වුනේ නැත්තේ? right, අකිල ඔයාට follow කරන්න තියෙන්නේ people හරි තපරක් ඉන්න මේ දෙවෙනි ප්‍රශ්නේ ලියන කට්ටිය දෙවෙනි ප්‍රශ්නේ ලියලා ඉවර කරගන්න. Then I'm going to go to the note again. අකිල contiguous allocation කියන තැනට පෙරලා ගන්න පුතා. right, ඒකේ පුතා ඔයාට manage කරන්න තියෙන්නේ file allocation table එකයි diagram එකයි තමයි compare කරගන්න තියෙන්නේ. right, එතකොට ඒකේ starting block එකක් තියෙනවා. file A ගත්තොත් starting block එකක් තියෙනවා. එතකොට බලන්න diagram එකේ start වෙලා තියෙන එතනින්. right? ඉතින් starting block එක 2 මේකේ file එකේ. එතකොට මෙතන අපි 2 කියන එකෙන් පටන් අරන් තියෙනවා. පටන් අරගෙන යාව පාට කරලා තියෙන්නේ අඳුරු කරලා තියෙන්නේ. right එකට එක patterns පාවිච්චි කරලා කමක් නැහැ. ඊට පස්සේ length එක තියෙනවා. first file එකේ length එක 3යි. එතකොට දෙකෙන් පටන් අරගෙන 2 3 4 කියන විදිහට blocks 3 පාට කරලා තියෙනවා. right මේ විදිහට 2 3 4 ඒක තමයි ෆයිල් A වලට අදාළව තියෙන්නේ. සෙකන්ඩ් එකෙන් ස්ටාර්ට් කරා length එක 3යි blocks 3ක් ගියා. ඊට පස්සේ ෆයිල් B එක 9th වලින් පටන් අරන් තියෙනවා. ඒ කියන්නේ මෙතනින් පටන් අරන් blocks 5ක් යනවා. 1 2 3 4 5 ඔය විදිහට. අකිල තේරුණාද? right හරි. කරන්න මට කරලා ලැබන්න අනිවාර්යෙන්. and yeah, I need the answers from Pahanmi and Bashita and Akila. Yes. Yes, Lalindi, I received the second one. Okay, so yes, yes. Right. Yes. Very good. Very good. Yes. 3 7 Yes, that's correct. Shalindi, very good. Go for the third one. Pahanmi, I receive yours. Let me see. Okay. Right, okay. Yes, that's correct.
සාර දෙවැනි කිස දෙකේ ඉඳන් 11ට වටින් තමයි යන්නේ එහෙමනොත් එහෙම කියවන්න
කියන්නේ ක්‍රොස් උනත් කමක් නැහැ මේ නිර්මාණ මේක එහෙම ලොකු ගැටලුවක් නැහැ right Pahanmi yes that's correct Dua very good go for the second one Right, Nikini? Yes, very good. Yes, though, yes. Right, that's correct. Okay. Yes. Yes, that's correct. That's correct, Dua. Good. Excuse me. Okay, Dua. Go for the third one. Well done. Nirmana. Right. Oh, Nirmana එක පොඩි තැනක් මිස් කරන් තියෙනවා. දැන් ෆයිල් A එකේ start block එක file allocation table එකෙන් අපි අරගන්න ඕනේ. එතනින් තමයි 7ට එන්නේ. right? ඔගේ අනිත් ටික හරි තුන්වෙනි block එකේ ඉඳලා තමයි නිර්මාණ 7 වෙනි එකට එන්න ඕනේ. ඒක start වෙන්නේ 3ෙන් කියලා තියෙනවනේ උඩ ප්‍රශ්නේ. clear ද නිර්මාණ?
හරි
right?
හරි
හරි.
ඒස තුන පාට කරලා යට ඊට ඉතලක් ගැවුණ හරිනේ හතරට
අන්න right. 3 ඉඳලා 7ට ඉතරයක් ගන්න ඕනේ. Akila, let me see. Right, okay. Yes. Yes, okay. Yes. අකිල පොඩි වැරද්දක් කරලා තියෙනවා. ඒ කියන්නේ ඔයා allocate කරලා තියෙන විදිය හරි. පුතා storage එක ඇඳගෙන තියෙන විදිහ වැරදි. මම අර storage එක අඳිනකොට කිව්වා නේද? ඒක කියලා තියෙනවනේ. Assume the storage has 24 blocks and the block numbering starting from 0. A block row contains 4 blocks. එතකොට you have to go on that method අකිල. එතකොට එක row එකක blocks 4යි තියෙන්න පුළුවන්. ඒ 4 ගානේ පේලි 6යි. right? එතකොට blocks 24යි 0 to 23 වෙනකම් number වෙනවා. right? ඒක මට හදලා ආයෙ එවන්න අකිල. right? And try the other two as well. And Sachintani, yeah, Dua, the file A is not starting from the 7th Dua. It is starting from 3rd one. Duage flow එක හරි තන පොඩි ගැටලුවක් තියෙනවා 7th වල ඉඳලා arrow එකක් 15th වලට අරගෙන තියෙනවා. එතන පොඩ්ඩක් වැරදි දුව. 7th වලින් 9th වලට නේ යන්නේ. Sachintani, Dua, you have to follow this order 7 to 9, 9 to 2, 2 to 11, 11 to 15. right? එතකොට ඒ arrows ටික දුව ඒ විදිහට යන්න ඕනේ 3 ඉඳලා පටන් ගන්නත් ඕනේ දුව. right? වැරද්ද හදලා මට එවන්න.
සයිඩෝට ඉන්ඩෙක්ස් එකෙත් තුනෙන්ද පටන් ගන්න ඕනේ කියන්නේ අපි.
මේකේ මම ඉන්ඩෙක්ස් බ්ලොක් එක ගැන කියලා තියෙනවද? ඔව් මම මේ ඉන්ඩෙක්ස් බ්ලොක් එක කියලා තියෙනවා ඕකේ.
හරි සර්. يعني ස්ටාර්ට් මේ බ්ලොක් 0 කියලා දීලා තියෙනවා.
ඔව් කියලා තියෙනවා.
හරි.
Right, Lalindi, I received the third answer. Let me see. Yes, okay. Yes, that's correct. Yes. Yes, that is correct, Dua. Very good. Very good. Sachintani, let me see. Yes, 7 to 9, 9 to 2, 2 to 7. දුව දැන් ඕඩර් එක හරි මේක දුව දැන් මේක කියලා තියෙන්නේ උඩ තියෙන ෆයිල් එකකට අදාළව කියලානේ. ඒතර ෆයිල් එකේ දුව ස්ටාර්ටින් බ්ලොක් එක අපි 3 කියලා කන්සිඩර් කරන්න ඕනේ දුව. Right? මේ කියලා තියෙන්නේ the other blocks which are linking to store the file are කියලානේ. So අර උඩ මේ file allocation table එකේ මම කියලා තියෙනවානේ A පටන් ගන්න third block එකකින් කියලා. So ඒකත් මෙතනට consider කරන්න ඕනේ. third block එකෙන් පටන් අරගෙන තමයි ඔය රටාව යන්න ඕනේ. ඒක දුවට කරන්න තියෙන්නේ third block එක පාට කරලා 3 to 7 ඊතලයක් අරගන්නයි තියෙන්නේ. Right? So ඒ amendment එක කරගන්න දුව. ඒක කරලා third question එකට යන්න. Right? And yes, Akila, yes, now it is correct, Akila. Yeah, that should be the way. Yes, yes. Go for the second and third one, Akila. Yes, Nikini, I got your answer. Let me see. Yes, yes, Nikini, that is correct, Dua, but only thing you have to specify the index, Dua. Right? අපි අර diagram එකේ පෙන්නලා තියෙනවා වගේ you should specify the index block, Dua, like this. Right? So do the amendment. Yes, yes, like that, like that. That's great. Very good. Others? So send me the answers as quickly as possible. Nirmana, let me see. Yes, that's good. Okay. One කියන block එකත් පාට කරන්න.
දැන් දැක්කේ මට.
හරි හරි. අයිට හරි අයිට හරි. Right, okay. Right. Right. Akila, this is the second question. Akila, second and third එක ලියා ගන්න. ලියාගෙන එතකොට ඔයාලට හදන්න පුළුවන්. Right. So I'm going to move forward. Sachintani, I receive your answer. Let me see that. Oh, yes. Sachintani, that is correct. But you have to show the index, Puta. Like it show over here. මෙතන මේ index එක පෙන්නලා තියෙනවා වගේ you have to show the index. Right? Akila, are you done writing the questions? And others, you have to send me the answers. Pahanmi and Bashita. Right. Right. So I'm going to move forward. There was another, yeah. Yeah, now this question, hold on, storage will block that. Yeah, අපි මේකට එමු තව ටිකකින් capacities ගැන කතා කරලා ඉවර වෙලා. Right? So That will be easier for you, right? Okay, so hari api fragmentation වලට යනවද නැත්නම් gates වලට යනවද? We'll do some gates නේද? Right, we'll do some gates, and later we'll come here and talk about the defragmentation and these things. Right. දැන් අපි allocation මෙතනින් ඉවරයි. අපි මෙතනට කතා කරමු. That will be much better කියලා හිතනවා. Yes. Okay, so people, I'm going to talk about the defragmentation, right? So as we talk about in the previous point, now defragmentation is the solution for the fragmentation, right? So defragmentation is the process where you can collect the things into a one particular place or into a one particular side of the disk, which is the data, and rest of the empty space into a one particular place, right? That is what you call disk defragmentation. So defragmentation, once defragmentation is done, it's going to look like this. Now these light blue places are the empty spaces. So you can see how the fragmented disk is happening. So once it is being defragmented, so you can see all the light blue places are arranged into a one particular place, and the data, which is given by the other colors, are allocated into a different particular places, right? So this is what we call, now from this picture, you can identify what is fragmentation. That is being, the data is being scattered around the disk, and then you can identify what is defragmentation. So what happens once we're done after the defragmentation, right? So then after, we are going to talk about a maintenance of the secondary storage. Now, when it comes to the maintenance of the secondary storage, the secondary storage are typically used to use these type of data. So they have temporary data, they have executable files, and they have data for the programs. Those are the one which is like most frequently, or like most of the capacity is held or like is been allocated for the data for the program. And the source programs. Source programs are the programs which can be executed, or like not actually be executed, which should be converted into a executable file, right? So in the Python, when you are doing the Python questions, you will see how to create a source programs, right? Sachin Tani, you have sent me the answer. Yes, though, that's right. That is what you need to have. Okay, right? So these kind of files will be there in the storage. So operating system will maintain the hard disk space to do the, or to allocate the places for these files, and in shortly for these files, right? So when they are doing that, operating system will use the previously that we talked about the allocation methods, so like the contiguous allocation, or the link allocation, or maybe the index allocation. So any kind of allocation will be taken by the operating system, that is due to the operating system, right? So then it will arrange the things on the disk with these components, right? So to, like, now for operating system to store the data in a hard disk, it can't just store the things in any hard disk. එයාට හම්බෙන ඕනම, එයාට ෆික්ස් කරන ඕනම hard disk එකක OS එකට බෑ ගිහිල්ලා data දාන්න, right? for operating system to identify that this particular computer is fixed with fixed with a hard disk, and hard disk has these kind of places to store the data, it needs to be formatted, and later it needs to be partitioned, right? So this is what we call disk formatting process, right? So when you are doing the disk formatting process, you can do the disk formatting process, but it's a very careful thing to do, right? Then ගෙදර මේක කියලා දුන්නාන් පස්සේ ගෙදර තියෙන disk format කරන්න එපා, because all your data is going to go, right? Going to vanish, right? Because formatting disk එකක්, ඒ කියන්නේ disk එකක් format කරොත් දැන්ට data තියෙන all the data will be deleted permanently, right? Later you will need a recovery software to recover the things in case if you got format your disks. All right, so I'll tell you what is actually happening over here, right? So when you purchase a particular disk from the market, right, a new and a fresh disk, it is not being formatted. So it is like a very clean disk that you are receiving, right? So before we store the data on it, we have to tell how these data, or like what is the structure for the data to be stored inside on this particular hard disk, right? මේක උඩට data දාන්න තියෙන structure එක මොකක්ද? නිකම්ම platter එක උඩට data එවන්න බෑ, right? So in that point, we need to say, or like we need to introduce a file structure to the operating system, as well as to the hard disk, right? The hard disk එකට අපි කියන්න ඕනේ මෙන්න මේ විදිහට තමයි ඔයාගේ data arrange කරන්න හදන්නේ, right? That is done by introducing a file system to the hard disk, right? So the very first thing that we have to do is we have to format the hard disk, right? So that is what we call low level formatting. So once you format the hard disk, during the formatting, it will ask what kind of a file system that you need to use. So there are different kinds of file systems other than the FAT and the NTFS, but most frequently one is the NTFS that we are using, right? So you can specify what kind of file system that you are going to use to do this, right? So once you've done the formatting, then you have to do the partitioning part, right? So now the file system know, hold on a second, people. Did I jam it? Just a second. Yeah, people, I'm very sorry. I think I mixed it up, right? Hold on. Clear the knowledge which I have gave regarding the disk formatting, right? Hear me out from the beginning. I'm sorry, right? So when you are having the disk for the very first time, what you are doing is you fix it to the computer or a formatting machine, and first you are going to divide this into the logical parts first, right? The hard disk එකක් මුලින්ම connect කරාම අපිට පේන්න තියෙන්නේ unpartitioned allocation එකක්, නැත්නම් unpartitioned space එකක්, right? ඒක හරියට අපි pen drive එකක් අරගත්තම දැන් එන pen drives නම් ගොඩක් වෙලාවට format කරපු pen drives එන්නේ, right? In early days when we purchase a pen drive, if we fix it to the machine will give us the message, this disk is not being formatted, you have to format this. At the pen drive, we don't need to create partitions for that. We can just format it and we can use that. Even for a hard disk, we don't need to partition. Partition කරනවා කියලා කියන්නේ කොටස් වලට කඩනවා කියන එක. Now if you open your file explorer in the computer, Now, these are the partitions that my hard disk has. I have two partitions, which is C and D, right? So first, when I purchase a particular hard disk, I have to create these partitions, right? And there you have the choice to have only one partition or have more, right? So once after you done with the partitioning, like breaking down the hard disk logically into several different parts, then you have to format each and every part separately, saying what is the file system that they are going to use, right? So first we are going to divide the hard disk into a logical spaces or the logical partitions. Then partition by partition, I have to say what is the file system that this partition is going to have, right? Now in your computer, you can see the details of this hard disk by using the disk management utility, right? So if you type disk management, sometimes මෙයාගේ නම වෙනස් වෙලා තියෙන්න පුළුවන් බලමු මෙයාට කියලා. Yes, disk management. එයාගේ menu එකේ තියෙන නම වෙනස්, මේකේ උඩ තියෙන නම disk management. So this disk management shows you what are the partitions that you have in your system, right? And you can see here, like in my computer, like 5 partitions are there. So these 3 partitions, they are system reserved partitions, right? They use for the, one part is used for the booting process and the other part is used as a backup of this C and D, right? As a recovery partition, right? So I majorly have 2 partitions, which is C and D, this one and this one. So you can see it is 136.79 GB NTFS, the file system. It says healthy. It says boot, crash dump, basic data partition, right? So that means this indicates this is the partition which contains the Windows files. That is why boot keyword is there. And in here, in the other one, it is saying 100 GB NTFS healthy page file, basic data partition. So it is just for the data. There is no any system files included inside it, right? Now, if we want, we can create more partitions out of these 2 partitions. Again, ඔගොල්ලෝ disk එක format කරන very first time එකේදී ඔයාට computer එකට operating system එක install කරන අතරම මේ partition එක කරගන්න පුළුවන්, right? That is partitioning during the installation process, operating system installation process. Or else you can fix your hard disk into a computer which has an operating system already. Then you can partition it using this disk management utility, right? මම මේ පෙන්වන්න හදන එක බොහොම පරිස්සමට ගිහිල්ලා බලනවා නම් බලන්න, නැත්නම් මෙතනින් විතරක් බලලා සැනසෙන්න, right? Now if I right click on this, I can have many different menu items: open, explore, change driver letter and path, shrink volume, properties, likewise. So if I choose shrink volume, it will calculate, it will do some calculate and give me some summary, right? This is little bit out of your syllabus, technical part, but it's better you know, right? So it will tell me the total size before shrink, 100 GB කියලා පෙන්නලා තිබ්බට 100 GB වලට පොඩ්ඩක් ලොකුයි, 102 විතර වගේ වෙන්න තියෙනවා, right? Then size of available string space in megabytes. Then make megabytes 45,889. So like it's almost equal to the 45 gigabytes, right? So that means out of this 100 GB, I can claim 45 GB amount of size as a separate partition. මම shrink කරනවා කියලා කියන්නේ මේ ලොකු partition එක කැලි දෙකකට තව කඩත හැකි මට. Right? So I can choose the space, the particular space, and I can click on the shrink button to do the shrinking. But for the moment, I'm not going to do a shrink, right? ඔය විදිහට ඔයාට shrink කරන්න පුළුවන් ඔයාට කැමති කොටසක් දැනටමත් තියෙන partition එකකින්. So once you shrink it, right, it will show as a non-formatted, format කරපු නැති part එකක් විදිහට මේ තියෙන list එකේ පෙන්නනවා. Unformatted part කියලා. Right? Then you have to format it to give it a particular file system. Right? එතකොට ඒක right click කරලා format කියන එකට ගියාම එයා අහනවා මොකද්ද format කරන්නේ, මොන විදිහටද format කරන්නේ, මොකද්ද පාවිච්චි කරන file system එක. So once we give those details, ඒක නිකන් tick කරන් තියෙන බොහොම සරල process එකක්. tick කරාම ඒක format වෙනවා. Right? Then you can see that particular partition is going to show on your file explorer. දැන් මම මේ D එක shrink කරොත් තව 45 GB එන්න හරි ඊට අඩු කැලලක් එන්න හරි. So I'm going to see CD and something else, not E definitely. E is given to the CD drive. So definitely it's going to be F. F drive එකකුත් මට බලා ගන්න පුළුවන්. Right? So likewise, now if you partition a disk, still it is not being recognized by the operating system. Once you format that particular disk, then only the operating system will be able to see what it is. Is that clear, people? Everyone? Right. Okay. Right. So that partitioning kind of things, we call it the low-level formatting, and the high-level formatting belongs to the introducing the file system. So it is like this. The new drive is very clean one. So first we partition that, right? So we have two particular spaces, which is C and D. Then we are going to format it. So once it is been formatted, then it is given a particular file structure. Then only it create the structure inside it. So අපිට මේ පොඩි කොටසක් block එකක් කියලා අඳුන ගන්න පුළුවන්. Right? ඒ blocks ටික හදාගන්නේ structure එක හදාගන්නේ once it is formatted. Right? So the next one is the recovery of data from a formatted disk. So now, what is recovering of data? මේක ගොඩක් අය ටිකක් පටලවල තේරුම් ගන්න concept එක. Right? So I'm going to describe the recovering part from this diagram. Now you know, in the other day I have told you, when we create a particular file, the data is really on a hard disk, right? In the ones and zeros format, right? And what we can see on the screen is a logical view of that. Now that is what that we have shown from the very first diagram over here, the leftmost one. Right, there is actual data, so link is there, so user visible file is there. So what we can see on the desktop is a logical file, the file, the representation for the user. So this is talking about a permanent deletion, right? අපිට temporary delete කරොත් we can restore it from the recycle bin. So this is not something like that. Now we are going to Onirman.
So එතකොට මේ after recovery කියනකොට link එක වෙනස් වෙනවද මොනවා හරි තියෙන link එකේ?
නෑ ඒක වෙන්නේ නැහැ. ඉන්නකෝ
Yeah
කියන්නේ.
sir වෙන පාටක් අරගෙන තියෙන්නේ.
නෑ ඒ repair වෙනවා කියන එක මම පෙන්නන්නයි.
හරි sir.
Right, so now when we are deleting a file permanently means we are breaking this link in between the actual data and the user visible file. Right, again අපි desktop එකේ තියෙන word file එකක් select කරලා shift delete එකක් දුන්නොත් so it will permanently delete it. Right, it will it will prompt you a warning box saying okay, your data is going to be deleted permanently. So then if you say yes, so it is going to delete permanently. It's not going to go to the recycle bin. That means your file is gone. You can't undo or take it back or whatever the thing you can't do. Right? So, but actually on a permanent deletion, what is happening is we are losing the link, or we are the link in between the actual data and the user visible data is broken. Right? Eka break karla logical view එක අයින් කරලා. So in case if we want to recover that, still my actual data is there on the disk. Right? So we can use a recovery tool and tell the operating system, I need this file again. So I need to have the repair of this link to my actual data. So you help us to repair the link. So then with the help of the operating system, it will repair the link so we can recover the file. But when you are recovering the files, be very careful to not to store new data after your deletion. Right? ඒ කියන්නේ ඔයා මොකක් හරි වැරදීමකින් ඔයාගේ data delete වුණොත් ඔයා recover කරන්නේ වැරදිලා delete කරපු හෝ නැත්නම් ඒ වෙලාවෙදී හිතන්න තු delete කළා පස්සේ ඔයාට අවශ්‍ය වෙන data එකක්. හැබැයි if you have written new data onto your disk after the deletion, delete කළේ වුණාන් පස්සේ අලුතෙන් data එකක් save කරොත් there is a risk of losing this actual data. The reason is we don't know which place of the hard disk that the operating system is going to allocate for the new data. Right? ඒක හරියට අර ගෙදර බිත්තියේ තීන්ත දාලා තියෙන බිත්තිය උඩින් තව තීන්ත ගන්නවා වගේ. නේද? operating system එකේ අපි data එකක් තියෙනකොට හිතන්නකො අපි බිත්තියේ පුරාම එක බින්දු තියෙනවා කියලා. Right? එතකොට බිත්තියට ඉස්සරහින් තියලා එල්ලලා තියෙන cardboard set එකක් අර බිත්තියේ තියෙන data එක link. එතකොට අපිට cardboard එක through බිත්තියේ තියෙන link එක තියෙන data refer කරන්න පුළුවන්. අපි delete කරනවා කියලා කියන්නේ අර අපිට බිත්තියේ ඉස්සරහින් තියෙන cardboard එක අපි ගලවලා අයින් කරනවා but still බිත්තියේ data ටික තියෙනවා. හැබැයි අපි අලුතින් data එකක් දැම්මොත් operating system එකට හැකියාව තියෙනවා අර බිත්තියේ තිබ්බ data එක මකලා අලුතින් data එකක් ලියන්න. සමහර විට අපි delete කරපු තැන ලියවෙන්න පුළුවන්. නොලියන්නත් පුළුවන් වෙන තැනක ඉඩ තියෙනවා නම්. Right? But the advice is, in case if you delete something, don't do any new writing part. Just take the device and do the recovery part. මොකද එහෙම recover කරොත් definitely you can recover the data because it is sure we haven't write anything new to the disk. So the actual data of our deleted file is there, so we can recover. Right? අපි අලුතෙන් data එකක් ඒකට දැම්මොත් then there is a very high risk to lose that old data from the hard disk. Right? So anyway, recovering means repairing the link in between the actual data and the user visible file. Is that clear, everyone? Okay, any questions regarding this? All right. Right, so that is regarding the file allocation, or like how they are going to manage the disk. File storage management is done. So the next topic is the most important topic of your operating system lesson, which is the process management. Right, let's take a start for that and let's end the session. Right now, process management means when your computer has programs, we can execute those with the help of the user or maybe the help of the operating system, right? Like all the programs which is installed into your computer is not going to start by the user. There are several programs that can be executed by the user, which helps for the user's day-to-day things. Rest of the programs and the services sometimes start from the operating system, right? And if you want to get to know about the processes that the that you have start on the computer, right click on the taskbar and go to the task manager, right? So the task manager will show what are the things that the user has started. So here I am running different kinds of programs. So these things which is start by me or which are started uh, on behalf of me. Again, සමහර ඒවා මම mark කරලා තියෙනවා operating system එක start වෙනකොටම start වෙන්න කියලා. So again, those are user programs, but it is starting automatically, right? But this WhatsApp desktop, Microsoft Whiteboard, Adobe Acrobat Reader, all these things, Zoom, I have to execute. This snip and sketch, it is also executed by me. HP pen control, that is starting with the booting process. එකෙන් තමයි මගේ pen එක screen එකට sensor කරන්නේ. But if you go for the more details, මෙතන මේ යට more details කියලා තියෙනවා. If you go for the more details, now you can see a list of programs which is running. මෙතන අපි start කරපු programs උත් තියෙනවා, and the all other programs are there in the operating system running at the moment, right? See, so 95% of the programs are executed or like start and executed by the operating system. We only involved with the with our particular programs which need us to take the help, right? So it shows you how the CPU works, how the memory allocation happens, how many disks is being taken, network and GPU, the things, right? Even if you go to the performance tab, it will show you the graphs, how the CPU is being used and the data are given, and then look at the data at the bottom of the CPU graph. It says utilization, the speed, and you can see the word processors, right? Can you see that? Let me take the magnifier. Right. Hold on, I need to fix my mouse into this. Yeah. Can you see it? Here, the processors. 253 processors are running for the moment. And there is another one called 3095 threads. And the handles, like how many? 116,742. Right? And there is uptime and something. And here it shows what is the base speed of the computer, how many sockets, how many cores are there. It has 4 cores. And logical processors, it says 8. So it is another technique that they are using. And these are the cache memories that is using. L1 cache is 256 kilobytes, L2 is 1 MB, L3 is 6 MB. Right? But we are focusing on this processors that's happening. I'll tell you what is a thread. Thread එකක් කියලා කියන්නේ process එකක් තව පොඩි පොඩි කොටස් වලට කැඩුවම. So these 250 processors are making these 3009 like 3000 odd number of threads, right? And it is handled by the operating system up to this much of amount. It can mean threads 3016 තමයි OS එක handle කරන්නේ. එයා ඒක handle කරනවා මෙන්න මේ කියන 115,000 ප්‍රමාණය, right? ඒක change කර execute කර RAM එකට දානවා, CPU එකට දානවා, execute කරනවා. So it is doing many different things, right? So now there is no any word called programs here, right? So it's always the processes. So one program can create many number of processes. Sometimes it will create only one process, but in most of the times it will create many processes. Now, if you see it clearly, right, let me get rid of this magnifier, right? Now, if you take these kind of processes, desktop window manager, it's just one process. Zoom sharing host, one process, right? And if you think about this Adobe collaboration synchronization, there are two processes. See, and Adobe RDRCEF, I don't know what it is, right? But it has 3 processes. Apache HTTP server, 2 processes, right? So likewise, if you Google input tool, there are like Chrome open karlana, Chrome open karama, Chrome processors paha hayak open karna, right? So likewise, so this NVIDIA, this is regarding the graphic processing unit. So it contains 4 processes, right? So that means when a program is executed, you are given many different kinds of processes, right? So how these processes are being managed, that is what we are going to learn by next week, right? So for the moment, just remember, process is a program in execution. This is a golden sentence, right? මේක ඒ විදිහටම අහලා තියෙනවා exams වල ඉදිරියටත් අහන්න පුළුවන්, right? So a process is basically a program in execution, and a program can create many processes, right? So today we only talked about the operating system. So by next week, I'm going to give the priority to the gates lesson first, then I'm going to move into the process management, right? Okay, so I'm going to end the session from here, right? And I'll see you on next week for the very same time, right? All right, so thank you very much, everyone. I'm going to end the session from here, right? Okay, people, have a nice weekend. Thank you very much. Thank you very much. Right, okay.
Thank you, sir.
Right, okay, Nirmana, thank you.